Good afternoon, class. Today we're going to talk about the third and final SPSS assignment. So far we have done primarily descriptive statistics, mean, median, mode, standard deviation. We've done a couple of t-tests and some correlations. Today we're going to talk about one-way ANOVA and factorial ANOVA, also known as two-way ANOVA. The data that we're working with is called SPSS number 3 in-class data. Our variables are gender, motivation, and items recalled. So if we look at our in-class document for the questions, we see that Dr. Martin is conducting a study on how recall differs across gender and motivation conditions. So we're going to read through the questions and conduct the appropriate data analysis for her study. The first question, what is the mean number of items recalled in this sample? So we head back to our data and look at items recalled. So this is just the mean. It's a descriptive statistic that we have done throughout the semester. So go to Analyze, Descriptive, and Frequencies. We see that our variable items recalled is in the appropriate box. Go to Stats and select Mean. Hit OK. And paste our syntax. Then we highlight it and run it. So this is our output. And here we see that the mean number of items recalled for the sample was 14.3667. If we round, that's going to be 14.37. Alright, so go back to our document and using complete sentences, go ahead and write that the mean number of items recalled for the sample was 14.37. Great. Now, moving on to number 2, we're going to conduct a one-way ANOVA assessing number of items recalled, our DV, across motivation condition, our IV. Report the results in APA style using complete sentences. Alright, so we head back to our data and go to Analyze. Now there are a couple ways that we can do the one-way ANOVA. The first being we go to Analyze, then Compare Means, and one-way ANOVA. Or we can do Analyze, General Linear Model, and Univariate. Now since this is the method that we'll be using for the factorial ANOVA, we'll go ahead and use this. So Analyze, GLM, and Univariate. And we see here that our dependent variable is going to be items recalled. So we put that in the appropriate box. And there's no box for independent variable, but SPSS shows that as fixed factor, or fixed factors. So we highlight our independent variable, in this case it's motivation, and put it in the fixed factors box. From there, we select post hoc. So anytime that we conduct a ANOVA, we're looking at 3 or more levels, 3 or more groups of the independent variable. So the ANOVA tells us that there are mean differences across those levels, but not necessarily where those differences are. So if the ANOVA analysis is significant, we need to do the post hoc test to tell us where the differences are. And it's essentially a series of t-tests. And the reason why we do the post hoc and the ANOVA instead of a series of t-tests is that doing just a series of t-tests would increase our family-wise error. And maybe we would have results that aren't truly significant, or we wouldn't find significance where there should be significance. So again, like type 1 and type 2 errors. So after we put motivation in the post hoc test box, we need to select a post hoc test. The most common will be Tukey. So make sure Tukey is selected. We're going to continue. Go to options. And we need to make sure that our means are displayed for our independent variable. And also we want our descriptive statistics and estimates of effect size. Hit continue and paste. Then we go to our syntax and highlight and run it. Alright, so once we do the ANOVA, we get several tables in our output. The first one shows us our N, or sample size, for each of the levels of our independent variable. So we have 10 in each. The next one shows our means for the DV across the levels of our IV. So the mean for those of the non-competitive motivation group was 11.5. So mean numbers of items recalled. Competitive 17 and control 14.6. So just kind of off the bat, we see that the competitive group had the highest number of items recalled. But we still need to know if that is significant. So we're going to go and look at this box, the test of between subject effects. So here, this is our ANOVA table. This is going to tell us if our OneWay ANOVA was in fact significant. So you want to look at sources first and look at our independent variable, which is motivation. So we go over, see our degrees of freedom was 2. So again, that's the number of groups minus 1. Our mean squared, and our F. So the F is kind of the ANOVA coefficient. That's why ANOVA is also called an F test. So our value of F was 7.692. And our significant value, so our p-value, was 0.002. And again, anytime that our p is less than 0.05, we do have a significant analysis. And so this box shows our effect size. So a lot of journals in research now require that people report the effect size, since it is kind of a better picture of the data analysis than significance alone. And the effect size for, or the measure of effect size for ANOVA is the partial eta squared. And that was 0.363. So, since we know that our ANOVA is significant, that in fact there are differences in means across our motivation conditions, we need to know what the differences are, like which groups, non-competitive, competitive, or control, were significantly different from one another. So then we scroll down to our post hoc table, and that tells us. So just to kind of get familiar with looking at this table, this is being compared to these. So we see that non-competitive compared to the competitive group was significantly different. So the mean difference was 5.5. And comparing, again, competitive to non-competitive, that's the same thing, still different. And control to non-competitive, not significant. Control to competitive, not significant. So here we see that the non-competitive group and the competitive group were significantly different from one another, whereby the competitive group scored significantly higher than the non-competitive group. So let's go ahead and report this. And like we've done with other statistics, we're going to first tell our reader what analysis we have done. So we're going to say a one-way ANOVA was conducted to assess differences in items recalled across motivation conditions. And our data analysis indicated that there were significant differences. So we're going to say F. Then in brackets, we put our degrees of freedom between and our degrees of freedom error. I believe that was 27. Yes, 27. Close the brackets. Then here we put the value of F, which was 7.692. And our P was less than 0.05 because it was significant. Now, since it was significant, we also need to indicate where that significance was. So we're going to say that the post hoc test indicated that participants in the competition group scored, quote, the mean, so the mean number of items they recalled. Going back to the table, competitive group recalled 17 items on average. Scored higher than the non-competitive group. Also quote that mean, and their mean numbers of items recalled was 11.5. And we are done with our one-way ANOVA and reporting our one-way ANOVA. So now we're going to move on to question number 3. Conduct a factorial ANOVA to assess numbers of items recalled across gender and motivation condition. So again, with the factorial ANOVA, you have one dependent variable and two independent variables. And each of those independent variables could have 2 or more levels or 2 or more conditions. And so with the factorial ANOVA, we can have main effects, so just significance with one IV on one DV, or an interaction. So an interaction is when you have significance with one of the independent variables times the second independent variable with mean differences on the dependent variable. So now we're going to go ahead and conduct that factorial ANOVA. We head back to our data, go back to analyze, GLM, and univariate. So since we did our one-way ANOVA, we already have the correct dependent variable and one of our IVs. We're going to go ahead and add the second one to the fixed factors. Now from here we need to change a few things. Go to model just to make sure that it has factorial, because that's what we're doing. Oops, don't need that. Post hoc. So just like we did with the one-way ANOVA, in case there is significance, we still want to look at the post hoc. And our 2 key is still selected. Then we're going to go to options. Alright, so here we want our means to be displayed for all of our independent variables, so the main effect, and also the interaction. And the interaction is represented by motivation times gender. So IV1 times IV2. And we have all of our other options selected. Going to go to continue and paste. So then we head back to our syntax and see here that our options are clear in our syntax. So we're going to go ahead and highlight and run. Alright, so just like with the OneWay ANOVA, it tells us our sample size for each of our independent variables. And we see the means for the DV for all of our independent variables and their groups. So just looking here, oh, and it also does the means by the interaction, or by IV1, in this case motivation, times gender. So you'll have the non-competitive group males, non-competitive group females. So those in the competitive group that are male had a mean of 15. Those in the competitive group that were female had a mean of 19, and so on. But we really want to know if this is significant. So looking at our test of between subject effects table, this is our ANOVA table. And similar to the OneWay ANOVA, we look at our sources and see our independent variable 1, motivation, and our independent variable 2, gender. And if you notice, our F value for motivation is different than our OneWay ANOVA, since the formula is a bit different and is also including gender. And if we look at motivation by gender, this is our interaction. So this is our factorial right here, our two-way ANOVA. We look at our F value, was 1.130, not significant. If we look at just gender, our F value was 6.158. Our significant, or our P value is 0.02, so that is significant. And just looking at motivation, F of 9.235, our P value was 0.001. So this tells us that there is a main effect for motivation, a main effect for gender, but there is not an interaction between motivation times gender. That F was not significant. And also to note here that you can kind of tell if your F is significant. If it's over 4, it's likely to be significant. Just as with the t-test, if your t value is over 2, it is likely to be significant. And then from here, we can go on and look at our means. And since we had a main effect for gender, we can see that overall, females recalled more items than male. And we don't need a post hoc test for this specifically because there are only 2 conditions. So we just know that females score significantly higher than males. Alright. So what we're going to do is go ahead and report our main effects, our significant main effects for motivation, and our main effect for gender. So the F for motivation was 9.235. Significance was less than 0.05. So go back to our document. Again, we always want to tell the reader what data analysis we conducted. So we're going to say a factorial ANOVA was conducted to assess number of items recalled across gender and motivation. And say data analysis indicated a main effect for motivation. So we have our F, our brackets, our degrees of freedom, and our degrees of freedom error is 24. So now it's different because of the presence of the interaction term. Degrees of freedom error is 24. Close bracket. And our F value for motivation was 9.235. And our P was significant. So P was less than 0.05. Now, just like with the other OneWay ANOVA, we also want to know where our significant differences were. So looking at our mean comparisons, again, the post-hoc test, the same is true that the competitive condition scored significantly higher than our non-competitive condition. And so we need to find the mean for that. So the mean for competitive is 17. The mean for non-competitive is 11.5. So data analysis indicates a main effect for motivation. That whereby the competitive group mean of 17 scored significantly higher than the non-competitive group. With a mean of 11.5. Just to make sure, yep, 17. Alright, we also had a main effect for gender. So we're going to say that the data analysis also indicated a main effect for gender. For F, brackets, since we only have two groups here, our degrees of freedom should only be 1. Yep. Our F value was 6.158. And our degrees of freedom error is still 24. So our F value was 6.158. P is also less than 0.05. Whereby females and our mean items recalled for women was 15.67. Where our females scored higher than males. We had a mean of 13.07. Alright, the last thing we need to do is indicate that we did not have a significant interaction. We're going to say there is not a significant interaction effect. So F, our degrees of freedom is going to be a bit different here. Degrees of freedom is 2. Error is still the same. And our value of F was 1.130. 1.130. And since this was not significant, we're going to say P equals NS. Alternatively, we could quote the exact p-value, which was 0.343, if I recall correctly. 340. But for now, we'll just leave it at P equals NS. And we are done reporting our factorial ANOVA results. Last thing we want to do is attach our syntax. So go through and highlight all of this text, copy, and paste. And we are officially done answering all the questions and conducting all of the data analysis. So again, today we calculated a mean, a one-way ANOVA, and a factorial or two-way ANOVA. For your homework, you'll be asked to do pretty much the exact same thing. And please remember to report your results, just like we did here. In complete sentences and reporting your findings, so the F value and P values in APA style. As always, send me an email if you have any questions, and see you later.